Six Sigma is often wrongly defined as 3.4 defects per million products. Six Sigma is actually defined as 3.4 defects per million opportunities. dpmo Six Sigma's goal is to improve all processes to that level or even better. dpmo, or defects per million opportunities, is one of the important Six Sigma metrics. This value allows you to determine how effective your process is. It also allows for a comparison between processes. A defect is defined as any part of a product or service that does not meet customer specifications or requirements, or causes customer dissatisfaction, or does not fulfill the functional or physical requirements. A product might contain many defects. It becomes defective only if can't do its intended function properly as expected by customer. dpmo shifts the measure from product to the process that builds the product by introducing the opportunity in the computation of quality. Consider a storybook which has been recently published but it has some typo errors. If the book in this condition get good sales, then this book is considered to be with defects. This is not yet a critical to quality as per the voice of the customer. It will become defective if the reader is not able to read content and understand the meanings properly. CTQ is critical to quality. Quality is fitness for use or meeting specification. In a production process, it is not possible to make all parameters to meet the specification exactly. Hence we need to focus on few parameters which are the most critical to quality. Hence CTQ is a key factor. Consider the warehouse, stocking the paper bundles to be exported. The carton used for packing have damages like, not closed properly, not properly labeled, thickness of paper. These defects are directly leading to a defective unit. In a manufacturing industry, cylindrical rods are made with characterizes diameter and length. This is used for automobile parts manufacturing. If the corresponding bar has defects like scratch, dust, shine, black patches, diameter, length, bend etc., opportunities are the total number of chances per unit to have a defect. Each opportunity must be independent of other opportunities and, like a unit, must be measurable and observable. The opportunity should directly relate to the customer CTQ. The total count of opportunities indicates the complexity of a product or service. First, start with understanding the needs of your customers. Voice of the customer is the process of gathering customer comments or quotes and translating them into issues and specifications. From these comments, issues and specifications come the customer CTQ, critical to quality, a product or service characteristic that must be met to satisfy a customer specification or requirement. Complexity is a measure of how complicated a particular product or service is. A more complex process will have more opportunities. While it is difficult to truly represent complexity accurately, generally complexity can be reasonably estimated by a simple count. This count is referred to as an opportunity count. Consider a company that produces starter motors in their line, and this consists of several processes. Each of the process output is assembled to form the grouped unit called a starter motor. Here the final assembly is considered to the computation. The final unit, that is the starter motor, has 5 critical quality characteristics. Here any out of specification on the CTQs will lead to a defective situation and will be counted as a defect for computation. A sample of 10 units are now taken and should represent the complete set of produced variation. The starter motor 1 has a problem with the CTQ diameter. In this case the unit is defective as at least one of the CTQ has failed. Hence the defect count is added as 1. Once all the units are checked, the defects are added and divided by the units and the opportunities. The DPU is the ratio of the defects by the total opportunity. When this is multiplied by million, it's converted to million opportunity. The dpmo is then converted to a sigma level based in a statistical table. A dpmo to sigma conversion table is used to convert the dpmo to the sigma level. By understanding the sigma level, it shall form as a baseline to understand the current position, so that targets and budgets shall be allocated based on this. When dpmo is developed for each stage of the process, the final or the aggregated dpmo could be considered as a composite index. This is computed by summing up all the defects that led to the defective and dividing by all the opportunity. The complete assembly is thus grouped to derive a dpmo index, which could again be compared with the sigma level to know where the product stands. The defects that led to a defective subcomponent is thus grouped with the CTQ at the assembled unit level, and the combined dpmo gives the index for this product. In new product development, a threshold index shall be set so that this part shall move from prototype to production once the index is reached. The most common way to calculate process yield is using the measure called the rolled throughput yield. The RTY is the probability of a defect-free output from a process. It is the probability of being able to pass a unit of product or service through the entire process defect-free. Rolled throughput yield is the probability of passing all in-process criteria for each step in a process, as well as the end process. This is obtained by multiplying the yield of the first-time yield from each process step. Consider an example where at each step RTY is obtained. The rolled throughput yield is achieved by multiplying each of the step yield. The throughput yield measures the ability of the process to produce defect-free units. The yield estimate considers defects that are passed to the customer, ignoring defects that are reworked. The RTY correlate much more closely with labor, cycle time, rework costs and other important management metrics. Defects per million opportunities constitutes a standard of measure that correlates failures of expected norms in any process. One failure per every million normative outcomes constitutes one dpmo. You can also use the dpmo to analyze the quality and stability of your production or new product introduction process. In a new product environment, the dpmo levels can be used as a trigger to determine if the production process of a new product is under control and ready to be transferred to production.